So now we're going to talk about end behavior of a power function. So I always think it's easiest to think about the basic ones. So think about an x squared function. Notice that it's a parabola and both ends go up, right? Or you could have a parabola like this where both ends go down. When we're talking about end behavior, we're talking about what happens at the extremes. When x gets really small or x gets really large, what's happening with the graph? That's what we mean by end behavior. I'll get into the notation in a minute. So remember, this was examples of x squared, right? The quadratic function. So when you have a function that's to an even power, they're going to behave similar to the x squared. So one thing to consider is p, the exponent, is it even? Okay, because that's going to mean something. Now, when we're talking about the end behavior here, we're talking about p being a whole number. By a whole number, we mean either 0, 1, 2, 3, like that. Okay. So when we talked about power functions, we said, oh, well, we can have negative numbers and fractions. But right now we're reducing it to when p is a whole number. Okay, so it can be 0 or 1, 2, 3, and so on and so forth. Okay. Actually, it really should be an integer because what happens at 0? It's a constant function, right? But anyway, all right, we'll skip over that part. So that's if p is even. So let's say it's x to the 10th power or x to the 12th power. Those are all power functions with even powers, okay? So that would be the p being even column. Well, the end behavior then depends on the coefficient, okay? So let's say you have a positive number here, 3x squared. So if k is greater than 0, then it's going to be this case right here. It's going to go up this way and up that way. Now, some books will write that just with those arrows. They'll say the end behavior is up to the left and up to the right, or something like that. I'm going to give you some notation in a minute, but we want to understand what's going on. So if you think about p being even and k being greater than 0, it's like you're putting both arms up in the air like a touchdown, okay? I don't know if that helps. There's a whole sheet of these you can find the cartoon stick figures with. Okay, what if x had been negative? Okay, so let's say you had a -2. Well, then now we're talking more about this case where it's going down to the left and down to the right. That's when k is less than 0, okay? All right, so that's for even functions. They work like a parabola. They don't have to be quadratic. It could be x to the 4th power or x to the 10th power, but the end behavior works the same, okay? If it's even, then, it's either both arms up, like a touchdown, or I guess both arms down if k is negative, like you're safe, like in baseball or something. I don't know. All right. Now, what if p is odd? Okay, if p is odd, it's going to work similar to the cubic function, right? Okay, so this would be x cubed, okay? But it could be any odd power, x to the 9th or x to the 11th, or, we could keep going and finding more. Okay, so if p is odd, if the coefficient is positive, like we have here in this first box, it's going to behave like the cubic curve. It's going to go down to the left and up to the right. Notice I've left a little gap. That's because there's an in-between part. We're going to talk about that later, but we're just talking about the end behavior, okay? Now, in the book, they flatten these out in the picture, in the diagrams. They kind of flatten it out as the exponent gets larger. Okay, so you can keep that in mind. But I'm mostly interested in you understanding end behavior. Now, if you want to picture for this with your arms. If you put your right arm up and your left arm down, it's kind of like the John Travolta pose in Saturday Night Fever, okay? All right, that's how we think of it. Okay, that's if the coefficient is positive. What if the coefficient's negative? Let's say you had negative 7x to the 9th. Well, then that's going to reflect about the x-axis, and so it's going to go, I'll show you the picture. It's going to, like if you had a cubic one, it'd reflect like that, kind of like that. And so it'd be going up to the left and down to the right, okay? So that's a chart for end behavior. It just has the arrows showing you which way it goes. So you want to remember that. You can practice that. I guess it's John Travolta being like left-handed or something. I don't know. All right, now we're going to talk about the notation and what this all means with end behavior. So when we're talking about end behavior, so let's go back to our diagram of the parabola. It's one we're familiar with the most, I guess. If I had this on, a Cartesian coordinate system, we're talking about when x is going toward negative infinity. So when x is approaching negative infinity, okay? So this is the notation we give. That's how it's read. X is approaching negative infinity. Then f of x, our function, in this case, is approaching positive infinity, right? Because it's going up to the left. Now, when x is approaching when x is approaching infinity, f of x, in this case, is approaching positive infinity. Okay? Now, let's do another one just for the notation. This video will be a little long. Okay. Oops. So let's say you had something like, I'll do a little Cartesian coordinate system. Let's say you had one like this. And when we just want to talk about end behavior, then I'll do it this way. As x is approaching negative infinity, what is f of x doing? In this case, this diagram right here, this we're doing this one right here, okay? F of x is approaching infinity in this case. Now, what happens when x is going this way? When x is approaching infinity? Then f of x, in this case, is approaching negative infinity. You kind of have to play around with these a little bit with the notation. It'll get easier. It takes a little bit of practice with that, but I wanted to explain the notation. It's in the book as well.